This is the OCR FSMQ Additional Maths course from 2019. There's only one paper, it's 2 hours long, and you're allowed a calculator. Let's get straight into it. This is the formula book, so I assume this is the things that we need for this paper because it's different to the specimens formula book, which is interesting. But come to think of it, I can't remember using this at all, so I don't know what's going on there. Anyway, first question is very straightforward. 5 people, you need to select 3 of them. It's 5, choose 3, or you can just do 5 times 4 times 3, because you've got 5 choices for the first position, 4 for the second, 3 for the third, because you can't use the same person twice. Very nice and easy. Good, next question. Again, nice and straightforward. Find the critical values by setting this equal to 0 and factorizing. Or you don't even have to set it equal to 0, you can just factorize and then say critical values at minus 3 and 4. And then what I tend to do, it's equal to or it's not strictly, it's equal to or less than. So we color the circles in, and then one way to do it if you're given the line like this is just test a value in the middle of these two, because what critical values mean is that the behavior changes either side, generally speaking, at least for a quadratic it does. So if you just test the value 0, put in 0 here and the thing works, which means you're connecting the 2 points up. Because 0 is the thing that works, 1 will be, and then it will stop working after this critical value here. Anyway, you get this, long story short. Question number 3. So you can differentiate this, of course. As soon as you see the words normal and stuff, you know you're thinking about gradients, thinking about differentiation. So differentiate it. You want the gradient of this at x equals 2. So you want to put in 2 into this, and you get a gradient of 6. The normal is perpendicular to the curve, and that means it's got the negative reciprocal of this gradient. So the gradient of this is minus 1 over 6. And you can set in, you can put it into this if you want to. You can use y minus y1 equals mx minus x1. It's completely up to you. But I just do this and then shove in the values x is 2 and y is 8 back into there. And you can work out c doing that, and you get this, and then you just put it into there and you get the answer. Good. Question number 4. So okay, well, it says sketch. I think I've actually plotted this. So when x is 0, it's 1/5 times 2 to the 0, which is 1/5. You've got a calculator, so you can do this and that. When x is 1, you get 1/5 times 2, which is 2/5. When x is 2, you get 4/5, and then when x is 3, you get 9/5, and so on. And I just kept doing that until I got there. And then I put in minus 1, you get 2 to the minus 1 is a half, so it's a fifth times a half, which is a tenth, which is all the way down there. Anyway, you know what an exponential looks like. It looks a bit like this, and you end up with something that looks a bit like that. It's cool. That's the best I could do in PowerPoint in that sketch. You'd have to be more accurate than that, I would think, but whatever. You get the idea. Solve this. Well, of course, you can just set it up, then you can times both sides by 5, and then you can take log to base 2 of both sides. You can type that into a calculator, and you get 3 very easy marks. You can verify on your graph if you want to that it looks to be roughly in the right place. 3 is roughly there, so we should end up being quite close to 4, which we are. Good. Question number 5. So follow log laws. We can't just raise everything to power 10 when the logs are like this. We want to have a single log equals a single log. So we say, okay, if we're adding these two logs, we can times the inputs instead. So this whole side here is log to base 10 of x times x plus 2. And this 3 by power law can move up to the top like this. This is, of course, 8. This is x squared plus 2x. But now we've got what I was saying, which is log of something equals log of something else. So now we can just cancel those two logs out to get this. Also sorting out what these two things are, and then of course this is nice and straightforward. From here we just solve. The only thing we need to do for the last mark is say that you can't put a negative number into a log, so you can't have the answer of minus 4 here. The only answer is 2, which is what I've got there. Good. This question here then. So first thing I'm thinking is just immediately draw the tan graph between 0 and 360. There it is. And tan theta equals 1.5. So 1.5 is up here somewhere. So we're looking for either this value or this value. Now, of course, if we put this into a calculator and do tan inverse of 1.5, we'll get this, which represents the 56 degrees that we've got roughly in this picture here. Okay, so where is the other value? Well, it's all the way over here, of course. And tan repeats itself every 180 degrees. So all I have to do is do 180 plus 56, and I get my answer of 236. And those will be my two answers. In this question, show detailed reason, find the exact values of sine theta. Now there's a couple of ways to do this, but I just thought get out a triangle and say if tan theta is 1.5, 1.5 is 3 over 2. If this is theta down here, or 56.3, which is what we worked out theta is, or at least one of the things that theta could be, then tan 56 over 3 is 3 over 2. Literally, sides of triangle 3 and 2. So that means that's 3 and that's 2. But of course, doing about Pythagoras here, we can get this as root 13, 2 squared plus 3 squared square rooted. And then, of course, sine of this same theta, sine of theta is 3 over root 13, opposite over hypotenuse. So the answer will be 3 over root 13, except we just need to check. It says exact values, which is interesting. And we just need to check, why does it say that? Well, it's because sine could be positive or negative, I guess. Because if I had used, I know I can't put this angle into a right angle triangle like this, obviously, but pretend you could, or just get out the sine graph. In a sense, you'd get the negative value. It doesn't make sense when you put it in the triangle, obviously, but if you think about the sine graph instead, we've got two values we can use. We can use 56.3, which was this one, which corresponds to a positive sine value as well. 56 is about here, corresponds to a positive sine value. But the other one, 236, corresponds to a negative sine value. So the logic there is that this value will be the same because of all the symmetry in the trig graphs, but the value will be negative. And so we'll have these two answers. It's a pretty good guess. I don't think you had to explain that logic at all, but as soon as you had exact values, it's a pretty good guess that it will just be plus or minus the one that you have. So yeah, I would just say that rather than thinking it through particularly carefully. The equation this is constant, has a root at x equals 2. So from factor theorem, if x is 2 as a root, that means f of 2 equals 0, and x minus 2 is a factor. That's what factor theorem says at the end. So obviously if I put in x as 2 into here, it should all work, which means of course I can find k as minus 2 very easily, which means I'm looking at this. But from what I said, factor theorem means that x minus 2 is a factor of this. Now you could do some polynomial division, or you could just say, okay, well that just means that this cubic equals x minus 2 times some quadratic. And even better than that, the quadratic I know has a single x squared term, because x squared times x gives me a single x cubed. And I also know it ends with a plus 1, because 1 times minus 2 is minus 2. So all I need to do is find the a here, and I can just compare the x terms. Minus 3 over here must be minus 2a plus 1, or 1 minus 2a. We can solve that, and we can get a is 2. 1 minus 2 times 2 is minus 3, so a is 2. And then this factorizes, I think, to x plus 1 squared, and so the solutions are plus 2, which we already had, and minus 1, which appears twice, but it's just the other root. I don't know why it says other roots. I guess you put minus 1 comma minus 1, I really don't know. It is, value brackets s, so yeah, could only be 1, and it is just minus 1. Good. So we have a fair coin here, they flip it, and they're playing this game where, I can't even remember what the game is. The game continues. Each toss ahead is limited from game. Okay, so if you get ahead, then you just lose, and you keep going until everyone's been eliminated. Okay, all students limited after the first toss of the coin. Well, that means all 5 students just get ahead, and that's how they lose. So they all just toss heads, which is 1/2 to the power 5, which is 1 over 32. Exactly 2 students are limited after the first toss, so we need 2 heads amongst the 5 in the first toss, and 2 in the second toss, and the third one needs to get a tail, and then we don't care because they've won automatically when the other 2 are out. So okay, well this is a bit like a binomial, right? You say 5 choose 2, you want any 2 of the 5 people, you can type 5 choose 2 into a calculator of course, you want 2 of them to get heads, and you want the other 3 to get tails. Of course this is just 1/2 to the power 5, because it happens to be a fair coin, but it doesn't really matter. I'm representing 5 choose 2, 2 of them get heads, 3 of them get tails, and then after that you also, so it's not an or, it's an also statement, which means we're timesing by, in the next round, 3 students left, you need 2 of them to get heads, and you need 1 to get a tail. So we need this to happen and this to happen straight afterwards, which means there's a times, and then this is saying we've got 3 students left, 2 of them needs to get a head, any 2 of them, I don't care, and those 2 getting heads is this, and then the 1 to get a tail is this, and you just type that straight into a calculator if you want to, or you can do some fraction work, you get this in the end. Number 9 then, this is just a GCSE iteration question. To show a change of sign, just put x equals 0 into here, you get minus 1. If you put x equals 1 into here, you get 1. And that means, therefore, because it's a continuous function, it's cubic, it goes from beneath the axis at minus 1 to above the axis at 1, and so it must cross the axis somewhere in between. There's a sign change, there must be a root in between. Any words to that effect will get you the mark there. Show this thing. Well, the last thing, you can actually, what you can do is you can just do this backwards. The last thing they must have done is square root. So they had x squared equals this thing, and then you can cross multiply that out to get x squared times x plus 2 equals x plus 1, and then we can see how this will work here. So if we add x plus 1 to both sides, we'll get this, And then remember the step was square this to get x squared and then times by this. So actually, if I take this and factorize out an x squared, I'll get this, then divide by x plus 2, and then of course square root, and we'll end up with this here. So you can, when you're doing these rearrangements, you can actually, if you want to, just leave a 10 centimeter gap on your page, start here, and then just rearrange upwards, up the page, until you arrive at the original statement. Like just write all the lines in backwards, leaving space above each one. And just go all the way backwards. You don't even need to rearrange properly. You just start here and end there, just working up the page. Or if you want to be a bit more conscientious, start here, work down the page, and then just write everything you've written upside down again, and then just highlight that as your work. Either way, these questions shouldn't really be too hard. Using the zero to form list, starting with this, okay, we put x equals 0.8 into here first, so we get this. We get an answer when we type into calculator, and then you should know the trick of just typing in your calculator, using the cursor buttons to replace this with ands and replace this with ands, and then just press equals a bunch more times. And you get some answers that look like this. And then we want this to 3 decimal places. And now what you can tell after you press equals a few times, and even more times if you want to, is that this 9 is stable. Because this, I think this bounds up at about 3/8 something. If you press equals enough times, you can just get the same number on the calculator over and over again. But the 9 is definitely stable. It might go to a 4 here, but I can't remember. I don't think it does. But the 9 is definitely stable, which means if you're looking at the first 3 decimal places, the 9 sends the 1 up to an 802. And we can just say the answer is that to 3 decimal places. Good. Number 10. So obviously we put this thing into there to get this. We expand out. Expand it properly, don't just square 2x and square k like a complete pleb. Rearrange this and we get exactly what they wanted us to, because, well, I haven't put brackets around this because I couldn't be bothered, but it doesn't make a difference. Hence find the values for k for which the line is a tangent. So if it's a tangent, you've got a circle, which is this one, and a line which looks like this. If there are 2 solutions, that's not tangent. Tangent means 1 solution. But of course, if there's 1 solution, that means the discriminant is equal to 0. So we can just take this equation that they made us get in the first place and set the discriminant to be 0. So a is 5, b is 4k, c is all of this. That's why they put that in brackets, to just help you out and remind you that all of that is c. Okay, so b squared minus 4ac, don't forget to square the 4 when you do b squared. That's the only thing to be careful of here, I think. Rearrange this and we get k is 5 or minus 5 when we square it. Of course, it can be both, so you put both. Good. Question number 11. So it's one of these efficiency problems, I guess. Making wooden toys, he can make small or large. I'll call the number of small toys he can make S and the number of large L. It takes 5 hours to make small, 8 hours to make large, maximum 60 hours a week. So inequality, given the time constraint, is 5 lots of S, the number of small toys, plus 8 lots of L, the number of large toys, has to be less than or equal to 60. Good, so that's our first mark. He needs to make at least 3 large toys. He needs to make the number of large toys no more than double small. And he never leaves toys unfinished, so he's never halfway through a toy by the end of the week. He's always got everything done. From this information, write down 2 more inequalities. Well, clearly, L needs to be bigger or equal to 3, because he needs to make at least 3 large a week. And L needs to be less than or equal to 2s. Those are our 2 more equalities. And now we're being asked to graph all of those. Now, it's given us an x and a y-axis, but I called the variables L and S. X and Y, sorry. So let's just replace X with S and Y with L, and then graph these 3 things. So we can think of this as Y greater or equal to 3, because that's what I'm calling the L axis. So that's going to be a horizontal line, and we need to be above that. This one here is just is Y less or equal to 2X. Well, 2X is just a line gradient 2, so it looks a bit like this, and we want to be below that. They're firm lines, of course, no dashed, because this is strictly less than or equal to. So that's why there's no dashes. And then this one here, you can rearrange it if you want to, completely up to you. This gradient's quite hard to use, so the easiest thing is to put the y-intercept down, which is at 7.5, and then set L to be 0 and solve. So it's just going to be 7.5 divided by this, which I believe is 12, which actually means I chose the axis the right way around, which is good, because 12 wouldn't have fitted up here. Glad I didn't have to do that all over again. And then we have a line like this, and that would be this one here. And now we need to be above this one and below these 2. So above that one, below the other 2. So we need to be in this triangle. Shade the regions not required, so just shade everywhere that's not that triangle and leave the triangle blank. I'm not an A-level geographer, so I can't be bothered to actually colour this in. I'm just going to say you would have to colour in everything except the triangle in the middle. Good. So that's the picture there. Find the number of maximum toys he can make. Now remember, he can only make an integer number of toys a week because he never finishes He never leaves a toy unfinished. He never starts one that he can't finish. So actually, the only things he can do in this triangle are the grid points. Like he can make, for example, 3 S's and 5 L's. Right? He can do that grid point, or this grid point, or this grid point, but he can't do anything in the middle. So actually, there's not very many points we need to look at. What's the maximum number of toys we can make? Well, here, for example, he would make 3 plus 5, which is 8. Over here, he would make 2 plus 4, which is 6. All the way over here, though, he makes 7 plus 3, which is 10, and that's the maximum number. So you just need to look for the grid points and make sure you count them properly. Lastly, he makes £28 profit for a small and 60 profit for a large. Let's just find out how much profit he makes in this case when he makes 7 small, 3 large. That's 28 times 7 plus 60 times 3, that makes this. But notice how much more profit he makes on a large. So maybe there's a grid point that means making a few more large toys and fewer small, but is slightly better. So I think the ones we should probably check are, well, this one seems the most obvious to check, because 4 and 5, that's definitely going to be better than 3 and 5, so I definitely don't need to check this. But I'll check this one, so that's 4 small, 5 large. That's a bigger profit. I should have probably, thinking about it, also checked this one, 5 small and 4 large. I think it ends up being in the middle of these two. Probably check that one for completion, but the correct answer is 4 and 12. Should have checked this. Maybe I should do it now. Can't be bothered. Oh well, we'll move on. You can do that on your own time. I think this point probably should have been checked. Not worth checking any of the others because they involve making less small for the same number of large, or less large, which is a bad idea. Good. That one's going to be the answer. Good. Question number 12. So we've got this point. Show that k is this. Well, if it passes through that point, that means when x is 5, y is 10. So we just put that into there, and we find k is minus 15 pretty quickly. Show there's a maximum value there. Well, you can just differentiate this. You could make the square if you wanted to, but I differentiated and set to be 0 for a stationary point. Of course, it's a maximum because this is an upside down quadratic. So I'll just state that it's max since it's a negative quadratic, it's upside down, it has a maximum point. So set that to be 0, you get x is 5. And of course, we already know when x is 5, it goes through y is 10. So that's enough to say that. The curve C2, so this was C1, curve C2 is this, has been plotted there for you. Sketch C1. Now this is a bit of a weird question. We know it, we just worked out it has a maximum at 5, 10, and it's an upside down quadratic, so it's a U shape a bit like this. I just decided to find the roots by setting y to be 0, and then flipping all these signs, because, sure. I just completed the square then really quickly and got this. And then in a calculator that gets you these two values, so it has a root just up here somewhere and over here. This appears to be the wrong thing to do because they should have given you more space on the picture if this was the right thing to do, but anyway, I just drew a curve through there. Okay, find the coordinates of the points. Now this is super confusing as well because if you look at the mark scheme, they've just written down the answers, which suggests that you're supposed to notice that the roots are at 6, 9 and 2, 1, which doesn't actually make sense on my graph because my sketch is just a tiny bit out. And of course, I don't know how you're supposed to sketch that so that it's not a tiny bit out unless you just plot it. That's probably what I have to do. You're probably just supposed to plot it. Yeah, you're probably just supposed to plot it so that it goes through the right points, even though it tells you to sketch. It's just a terrible paper. Anyway, so what I did was I just set the two things equal to each other and solved. Of course, I got the answers of 2 and 6, which means the y coordinates of 9 and 1, which means my graph is ever so slightly drawn in the wrong place, but it's okay. Those are the two solutions. And then find the area between the curves. So we need to integrate the top curve, which is the upside down one, which is that one, between 6 and 2, and then integrate the bottom curve again between 6 and 2, and just take away the second result from the first. So just to clarify, it's this, integrating the upside down one between 6 and 2, take away the other one between 6 and 2. Now, if you're integrating two things between the same bounds, you can just put them together and do one integral. So you can just do this. Of course, we can simplify that though, and then we can start integrating. I actually factored out -2 just to make the integration slightly easier. It's completely up to you whether or not you agree with that. And then, of course, you put in 6 into all of these values, and then take away the result when you put in 2 into all of the values. So it looks a bit like this. Type all of it into a calculator. You can literally just type this entire thing in now, I guess, with enough brackets, and you get the answer of 64/3. Good. So nice trig question here. This picture here is a 3D image. So it comes out of the page. This is a mast here. This is the ground, this triangle 300, 400, 60. That's the triangle on the ground. And then this is coming out of the ground upwards. And this angle here, it says, according to the thing, is 7 degrees. There. So let's draw this triangle out because it's asking us for the height of the mast, I think. So let's draw this left triangle out like this, and we get tan 7 is equal to 8 opposite over adjacent, and then we can solve that for 36.8. So height is 36.8 meters. Now find the angle of elevation from B. So we're looking for this angle here. So let's draw this triangle out on this side. And now the only information I have is the thing that I had there. So how do I get some more stuff? Well, just looking at this picture, all I need is the bottom. Because if I had the bottom, I could do inverse tan, a bit like this, but the other way around. So I just need this length, which looking at this triangle, I can do because I can just call it y and call this one y, and say if I do some cosine rule, I'm going to find y. So y squared equals this squared plus this squared minus 2 lots of this times this cos this. Type all of that into a calculator, square root the whole thing, you get this. So that's this, and then do tan inverse of that over that, and you get the answer of 5.83 degrees. So that's that little angle there. Now last bit, find the bearing of the base of the mast from B. So we need to put a north line in first, and we're finding the bearing from B. So north is a bit weird because it's not actually pointing up northwards. It's pointing diagonally. It's following this line here. If you read the question carefully, it's saying T is due north of A. So north is this way. So if I just continue that line on for a bit and then draw a parallel one here, that's the north from B, and I'm looking for this angle because of course you go clockwise all the way around there. So how do I do this? Well, what I decided to do was find this angle first. I called it A, even though there's a C right there, which I'm now looking at. But I called this angle A and said sine of A over 400 is equal to 360.6 over sine of 60, whichever way around that was supposed to be, I guess. And then you can solve this by typing that into a calculator, timesing by 400 and doing sine inverse, and you get this. So that's that angle. And then this angle, because it's on a straight line, remember, this angle between this north line and here on the ground, this angle there, is 180 minus this, which is this. And then, of course, by co-interior angles, this angle is 180 minus that, which is actually the same as A, of course, because you've got alternate angles here. So this angle is 72.9 as well on the ground here, going around this north line. And then, of course, the bearing from B all the way to here is just 360 take away this, which is going to be that there. Bearings are always 3 digits, so you never put a decimal point, and the answer will just be that. We're on to the last question then. So it starts off just being nice SUVAT question. I mean, basically, as soon as you read anything like this, your brain should just start thinking SUVAT, I think. Like it just should. You've got 50 meters, so S is 50. You've got initial speed of 14, you've got final speed of 9, and you're being asked for the deceleration and the time. So first we'll look for the SUVAT equation without time in it, so we can find acceleration, which is this one. Pop in the numbers, solve for A, and you get this. And then, of course, now that you've got A, you can use any SUVAT equation you want. I just, out of habit, just in case I've somehow messed up A, I tend to use the equation without the one that I just found, because then I at least know these numbers are correct. But, I mean, yeah, whatever. You find T as this, and that's going to be part A. Immediately after the bump, he accelerates with a variable acceleration this time. So now we're not doing SUVAT, because SUVAT only works for constant acceleration. I know this is variable acceleration because there's a system here where if you're given v in terms of time, the differential of that is the acceleration in terms of time, and the integral is the displacement. So first it's asking us first it's asking show he reaches zero speed in 10 seconds. So just shove 10 into there, and you find v is 14 very quickly. So that's just that done. And then next it says find the distance traveled. So we have to integrate v for the displacement, or the distance, I guess. It's claiming to be. So we integrate this thing here, which is equals this, I think. You can just integrate these bits and ignore the 1 over 100, and then of course integrate this. I've added a plus c. I'll also just expand this out a little bit. The plus c you can just set to be 0, because you can say, well, we're starting at the speed bump that he's just cleared, and I don't care about any distance that he traveled before then, so we'll just set the distance up to that point as 0, which means just setting c to be 0, because then when t is 0, the distance is 0, which is what I kind of just wanted to be. So we'll just set z to be 0 here, and just get this. And now we can just say, well, he reaches the speed after 10 seconds, it said, so we just shove in 10 as into here, and we get our answer of 115. Good. Find the maximum acceleration in this period. So as I said, acceleration is not the integral of velocity, but it's the differential. So we take this and we differentiate it this time, and we get this. If we just differentiate these bits, 9 goes away, of course. And maximum acceleration, well, if I expand this out, we see it's a quadratic. So to find the maximum value of the acceleration, I could just differentiate this and set it to 0, because I'm just looking for the maximum point of this quadratic. So that's what I did. I just differentiated, which is this. I set that to 0. Times by 100, and then you get t as 5, and of course that's the time it takes for his acceleration to be a maximum. But to find the actual value of maximum acceleration, we put that value into here, and we get A is 0.75. If all drivers do exactly the same, behave in the same way as Paul, suggest the maximum distance between bumps. Well, okay, so Paul took 10 seconds to get to 14 meters per second, which is the maximum speed that the road makers want people to go. So it took him 10 seconds to get there, and then looking all the way back, it took him 5 seconds to decelerate down to 9. So he's going in cycles of 10 seconds to accelerate to 14 from the previous speed bump, and then 5 seconds to decelerate back down to 9 to the next one. So that's 15. So that's. Am I saying 5 seconds? Why am I saying 5 seconds? It was like 4.38, wasn't it? It was. I'm actually thinking about the distance. It was 115 meters in the 10 seconds of this behavior of acceleration, and then 50 meters to decelerate. So we just add the 115 that he was accelerating up to 14 meters per second for, and then 50 meters that he was going back down to 9 for. Just add those two values, and we get an answer of 165 meters, which is the distance they should set them apart. It took him. I was talking seconds earlier, wasn't it? It took him 10 seconds, and then this was like 4 point something seconds, I think. But anyway, it doesn't matter. They're asking for distance, so I think this will be the answer there.